Hey class, today we are starting a new chapter, chapter 4, linear relationships, and we'll be beginning with exercise 4a, solving linear equations. This is all review of what we've done in the last year or so. We will just be writing it a little bit differently to what you're used to from year 7 and 8 and building on what you learned in year 9. So to solve a linear equation, you need to perform inverse operations until the polynomial is isolated on one side of the equation, so it's got to be on its own with the solution on the other side of the equals sign. We'll give it a shot with an example. So we've got 2x takes 6 divided by 3 equals 12, and we need to solve for x. So x is here. We need to get it on its own on this side of the equation, and to do that, we'll use the opposite of BODMAS. Okay, or BIDMAS. We need to work backwards when we rearrange equations. So when we substitute and evaluate, we work this way. Okay. To rearrange the equation, we need to do the reverse of that. So because we've got a fraction, please keep in mind that the 2x minus 6 is together and all of that is divided by 3. So the first thing that we'll reverse is this here, divided by 3. The opposite of divide by 3 is times by 3. So we'll do that to both sides of the equation. That will then cancel out. And we get 2x takes 6 equals 36. So 12 times 3 is 36. And we continue. Now, using BODMAS again, the reverse of that, we're looking for additions or subtractions to get rid of first. And we've got a minus 6, so we'll add 6 to both sides to cancel that out. That now gives us 2x on the left-hand side equals 42 on the right-hand side. Finally, we've got a times 2 here, so 2 times x. To get rid of the 2 times, we need to do divided by 2. And we do that to both sides one more time. And that gives us our solution of x equals 21. Let's try another. This time we've got negative 5 divided by 3x equals 4. There's a few ways you can go about this. I'll do it step by step. Here we've got the x in the denominator of the fraction, which makes things a little bit trickier, but not really. So we need to get rid of this divided by. To do that, we will multiply both sides by 3x. Okay, that's then going to get rid of the 3x in the denominator and put it back in effectively the numerator over here. So we get negative 5 equals 4 times 3 is 12x, which is the same as saying 12x divided by 1. So instead of the x being in the denominator as it was here, it's now in the numerator. And we can continue as normal. So we want, this time the x is over here, and it doesn't really matter which side of the equal sign that it's on, because we still want to get it on its own. So we'll divide by 12 to get rid of that multiplied by 12. And we're going to write the answer a little bit more neatly. You can flip it if you'd like. X equals negative 5 over 12. You might notice that we had negative 5 over 3 times 4, so 3 times 4 is 12. Effectively, we could have just swapped the x and the 4, so we could have taken the x out of the denominator here and swapped it with whatever was on the other side. Okay, so there's your shortcut for that, but this is the E step by step if you need it. One more equation before we step it up a little bit. When we've got x on both sides of the equation, your first step should always be to collect like terms, okay? So like we did in our previous chapter with algebra, we've got an x here and we've got an 2x here. My tip for you is to look for the x value that has the smallest coefficient. So here, x has a coefficient of negative 1. And I'll pick a different color pen to write that in for you. Let's go, yeah. Okay, so here we've got a coefficient of negative 1, and here we've got a coefficient of positive 2. So we're going to go with the -1 because that is in fact smaller than +2. And we're going to do the opposite of this. So instead of subtracting 1x, we're going to add 1x on both sides. So still doing the inverse, but that will cancel that out. And now we have 4 equals 2x plus another x. If I've got 2 apples and I buy another apple, I have 3 apples, so 3x minus 2. And now we can continue like we have been. The opposite of take 2 is +2, or the inverse operation. That's now gone, and we end up with 4 plus 2 is 6 equals 3x. And finally, we need to get x on its own. We've got 3 times x, so we'll divide by 3 on both sides. Okay, so the balanced model involves doing the same thing to both sides. And that just gives us 2 equals x, or x equals 2. If you want to write it around that way, it does not particularly matter. All right, one more example. This time we're going to use a literal equation. So literal equations contain 2 or more different pronumerals. What that means is that when we solve for x, x will be in terms of other letters or pronumerals instead of as just a number. So we're going to end up with a little more complicated looking an answer, but we're using exactly the same steps we have been. So we'll give it a go. We still want to get x on its own. The question still says solve for x. Okay. Working backwards. Okay, so we've got brackets. We'll deal with those last. Before we've got the brackets, we have a 2 out here. So we need to divide both sides by 2. That will cancel that out. Okay, so we end up with just x plus y. We can get rid of the brackets now because that's all that's left. It doesn't particularly matter if you have them in brackets or not, because you're going to be solving this regardless. Equals v over 2. And finally, to get x on its own, the opposite of plus y, if it was a +3, we'd minus 3. So because it's a y, we're just going to minus y. And we'll do the same thing over here. I'm writing it a little bit more neatly. We get x equals v over 2 minus y. Okay, and the minus y does have to be outside of the fraction component because it's not also divided by 2. And that is all there is to it. So it's exactly the same step, just instead of having numbers, we've got letters. As always, if you have any question, guys, feel free to contact me either through Teams or email, and I will get back to you as soon as I can. Good luck with the work.